Hey guys, today we're going to be looking at the SUVAT equations. Now in the previous video, you derived them. You found out where they came from, all right? What I'd like to do today in this video and the next one is kind of talk to you a little bit about how we can actually use them. What's the purpose? Why do we need 4 of them? Okay, hopefully got a little bit of that from that introductory video, but hey, let's go into some different questions and actually see how we use them. Now, as I go through this, I'm going to use them semi-formally, okay? The reason for this is because the problems will get more complex later on. Right now, we're just doing one-dimensional, right? Going forward and backwards. Eventually, we're going to be doing more complex questions. We'll have 2 dimensions. We'll have gravity, all these other things. And so we want to be able to deal with it in such a way that we don't have to change our way of using these equations or change our way of approaching a question. Okay, so we're going to approach each of these the same way and then figure out how we can use the SUVAT. All right, so let's get started. Here's our first question. A particle has an initial velocity of 12 meters per second and a constant acceleration of -3 meters per second squared, and it wants us to find the time at which it will come to rest. All right, now the way that we're going to do this is we're going to write down all the information that we have. Okay, now we should be able to look at this and recognize that it's a SUVAT type question because it gives us a velocity, it gives us an acceleration, right? Those things should point us to this idea of, this could be SUVAT. So what we're going to do is we're going to make a little table and we're going to have S, U, V, A, and T. Now you should know what each of those things are, right? You should know that S is displacement, U is initial velocity, V is final velocity, A is acceleration, and T is time. All right, so we're going to get whatever we can from our initial problem statement here, right? It tells us that the initial velocity is 12 meters a second. So we're going to go ahead and put that in as the initial velocity. So that's U right here. So that's 12 meters per second. When I put it in here, I'm going to make sure that it's in SI units, right? So I'm going to make sure that I'm in those fundamental quantities in SI units. Not fundamental, but broken down so that it's in those SI units to make sure that when I do the calculations, it comes out giving me the correct magnitudes and things like that. Okay, so I got 12 meters a second. What else does it give me in this question? Yeah, it gives me the -3 meters per second squared, which is acceleration. Okay, so -3 meters per second squared. Now, what other piece of information does it give me? It gives me one more piece of information, and then it asks for a piece of information. Now, the other piece isn't as obvious as the other 2, but it's there. This is very common for SUVAT equations to very clearly give you a couple of pieces of information, but then the third one you kind of dig and search for it a little bit more, right? The third piece of information is actually in the question, right? In the question itself, it says find the time when it is at rest. If it's at rest, which of these do I know? I know the final velocity. The final velocity, in order for it to be at rest, is 0 meters per second. Now, it doesn't necessarily mean it's going to stay at 0 meters per second. It just means at that instant in time, at that point in time, it is at rest. It's traveling 0 meters per second. Now, of course, now we have the 3 pieces of data that we have. The next thing that we need to know is what exactly is it asking for. Now, on this one, it's pretty clear. It says find the time. And so time is what I need right here. That's what I want. Okay, so I'm going to put that in my table as well because that way I know what I have and what I need. Okay, now if you look at these, you'll notice that we have 3 pieces of information. We want 1. All of your SUVAT equations have 4 variables, which means if you have 3 of them, you can find the 4th. So what do we want? We want the one SUVAT equation that has initial velocity, final velocity, acceleration, and time, and does not have displacement. All right, so we're going to go and look, and we'll say, well, this one has velocity, initial velocity, acceleration, and time, and no displacement. So that's the one we want. You'll notice that each of these others has displacement, displacement, displacement. So I don't want those because displacement means nothing to me in this question. So I'm going to go ahead, and I'm going to use the displacement here. The one without the displacement, which is the V equals UAT. So V equals U plus AT. From there, I should just be able to put the numbers in and solve for what I need to solve for. And so I'm going to put in U, which is 12. It It's in meters per second. Like I said, I'm going to put it in here in SI because then I don't have to worry about it later. So it's in SI, so I just put 12. V is 0, so 0 equals 12 plus the acceleration, which is -3, times t, which is what I'm looking for. At this point, I should be able to solve. I'm going to subtract the 12 to both sides. -12 equals -3t. Divide both sides by -3, and I get 4 equals t. Now, because it's in SI, I already know the units of t, which is 4 seconds. So I know that it will take 4 seconds for it to become to rest. Now, I know what you're saying. I know what you're saying is, oh, well, Mr. Bauer, I could have looked at that question. I could give the answer in 30 seconds. Okay, I understand that. I can do that as well, but that's not the point. The point here of this video is we're trying to learn how to use the SUVAT equation. We're trying to learn how to approach a question, not just this question, but any question. Okay, and I want you to understand that by doing this, we can solve a broad variety of questions, not just a specific question. All right, we'll talk about that more in class. Let's look at another example. All right, so let's move on to the next one, which says a go-kart is initially traveling at a speed of 2 meters per second. If it accelerates at 4 meters per second squared, find its displacement after 10 seconds. So again, I can tell by reading it, it's got some information there. We're going to go ahead and look at it as if it were a SUVAT problem. So I'm going to write down my table, S-U-V-A-T. All right, I'm going to go through and find what I can find. Okay, obviously right here it gives me a speed of 2 meters a second. That's my initially traveling, so I'm going to put that in, 2 meters per second. My velocity, let's see what else. It gives me my acceleration at 4 meters per second squared. So I'm going to put that in, 4 meters per second squared. And then it gives me a time. It gives me a time of 10 seconds. All right? Now, what is it asking for? So I got I've got all the information that I got there. So now what is it asking for? It is asking for find its displacement. It could ask for the position or the change in, whatever. Or if it's traveling in a straight line, it could just say, what is the distance that it traveled? Okay? But in this situation, we're going to say, all right, that's what I want. I want the displacement. So you'll notice that I didn't change how I'm approaching this question. It's a SUVAT, therefore I follow this process. Okay? So now with this process, I can now choose the equation that I want. Notice that the thing that I don't want is the velocity. So I go over to my SUVAT equations. Right here. And when I have my SUVAT equation, I say, nope, that one's got velocity. I don't want that one. Oh, that looks promising. No final velocity, so it's probably that one. I don't want this one. I don't want that one. And so here we go. I'm going to use that one right there. I'm going to use the S equals UT plus 1/2 AT squared. So I'm going to write that out just that way, and then we're going to solve it. All right? So here we go. We go S equals UT plus 1/2 AT squared. I know what some of you saying. Some of you sitting there saying, Mr. Bauer, do we have to write out the equation? I just put the numbers in. Okay, I understand that. I understand you want to do that. I understand that you are smarter than I am, but I'm going to write the equation down. And I guarantee you that I'm going to get the question right. Okay? Your choice, but if it's me, I'm always going to write the equation down, and then I'm going to put the numbers in because I want to make sure that I do things correctly. But, if you're smarter than me, go ahead. Do what you want. It's up to you. All right, so we'll go ahead and throw these numbers in. We got S, which is what we're looking for. We've got U, which was 2. We've got T, which was 10. Notice again, because these are all in SI units, I don't have to worry about the units on them, all right? And so I've got my 10 here for my time, and then I go plus 1/2 times the acceleration, which is 4, and then times the time again, 10 squared. Okay? At this point, you should be able to just plug that in your calculator if you need to. You can also just kind of think through it in your brain. I got 2 times 10, which is 20. And then I got 1/2 of 4, which is 2. 10 squared is 100, so 2 times 100 is 200. So there we go. Sorry, my marker's starting to die. I should have figured that out before I started this dang video. And then we go S equals 220 SI units, meters. Now, if you want to keep the meters, the units in there, that's fine. You keep the units in there and make sure that all the units cancel out. Nothing wrong with that, okay? My thing is, you know what, if I've got everything in SI units, it's going to give me the units that I want, okay? Don't get lazy, though. If you're going to do that, you have to make sure that everything is in SI units. If it's not in SI units, you need to write the units in there, make sure that the units work out properly, that you can cancel them out, everything else, all right? Only time I think it's okay to not put it in there is if you know that everything's in SI units, all right? Okay, hey, let's do one more. Why not? I got it right here. All right, so we got a remote control car starting with a velocity of 5 meters a second. After 2 meters of travel, the velocity is 7 meters a second. Find the average acceleration of the car. So we're going to go through this one a little bit faster because we've done a couple now. We should be able to kind of just go through. And I'm going to get rid of this red marker because obviously it doesn't work very well anymore. So here we go. Again, clues me in that it's probably SUVAT because it's talking about velocities, accelerations, that kind of stuff. So here we go. Here's my table. S, U, V, A, T, SUVAT. S is, let's see, what have they given me? It says it starts with a velocity of 5 meters a second. That's initial velocity. So initial velocity is going to be 5. Okay, meters per second. All right, after 2 meters of travel, M is meters. If it wants minutes, they'll have to put something else. M is meters, all right? So 2 meters of travel, so that's my displacement. So 2 meters, all right? The velocity is 7 meters per second, so that's what it is when I'm done counting this time. Something to be sure of is that when you do these types of questions, beginning and end don't have to mean the beginning of all time and the end of all time. Beginning and end can just be the beginning and end of an interval, right? You could have started your situation an hour ago and you could say, all I really care about is what's happening now. So I'm going to start my stopwatch at this point in time and go until here. And then what was your final time? That could be the initial time for some other situation. Okay, so final, initial are kind of flexible. It's just the final and initial times or velocities or accelerations of what we're looking at now. Okay, so here we go. We're looking at 2, 5, and 7. It says find the average acceleration of the car. So we are assuming that the acceleration is the same or that all we care about is the average. That is one thing to be careful of with these SUVAT equations, is that the SUVAT equations only work if your acceleration is constant or if all you care about is the average acceleration. If you want to know the acceleration at a specific point in time and the acceleration is changing, this isn't valid anymore, okay? So you have to be very, very careful in that you really only are going to use the SUVAT if you know the acceleration is constant or if it's okay to make the assumption that it is more or less constant. You're looking for an average in this situation. All right, so we've got the piece of information that we found. It's asking me for find the average acceleration, so that's A. So I'm going to write down that that's what I'm looking for, A right there. Okay, so what I need is the equation that doesn't have time in it. So I'm going to go look at the other equations and see what there is and see if there's anything that doesn't have time. So here we go. Here's my equations. This one has time. I don't really want that one. This one has time. I don't really want that one. This one has time. I don't really want that one. So that leaves me with this one. V squared equals U squared plus 2AS. So here we go. V squared equals U squared plus 2AS. From here, you can throw your numbers in, right? So I throw in my V, which is 7. So 7 squared equals U. So 5 squared plus 2 times the acceleration times S. And from here, you should be able to solve. Okay? So we've got 49 equals 25 plus 4A. Subtract the 25. And I get 24 equals 4A. So therefore A equals 6 meters per second squared. And we got our answer. Please always remember to put your units on the answer. Okay, it's okay to work without them if you're in SI, but in the end, make sure All right. Okay, that's it for this video. Hopefully that makes sense. If you want to see a couple harder ones, more complex ones, you can check out the other video. One thing I want to mention is, you know what, this is just a manner of approaching a question, all right? There are other ways to do these. Some of them you can do quicker in other ways, but what I want you to do is to have one method that works all the time for all of these SUVATs, okay? And this is what it is, okay? Some of these have other ways of doing it. For example, this one, if I used a different equation, a different SUVAT equation, right? I had the velocities and the displacement. So I could have, say, used the velocities and the displacement here to find time, right? Once I have time, I can use time with any of the other sets to then solve for acceleration. Right, I can make it a two-step. It just kind of depends on what you need and what you want to do with it, and of course whether you want the fastest way. Okay, most of the time that is kind of what we're looking for, is which of these is going to support us the most. All right, or the quickest. That's it for now. Watch the next one. See you next time.